The very warm welcome. I will try to share my slides now. So just tell me if it works. I hope yes. Yeah. Can you see the slides? Yeah, perfect. Okay. So welcome everybody to today's EGI webinar regarding the managing research in artifacts with the EGI Artefact Registry. I will try to go through the 3 or 4 topics. The motivation why we need to manage those artifacts and in some proper way. They are key part in infrastructure building or operating the services or doing some computational workflows. Because without them being available, the service or the workflow would fail. So you need usually some safe place where you can store those artifacts and reuse them in the computing infrastructure, but also with your colleagues from your team when you are building some kind of a software and you want a reproducible environment to have from the beginning, basically. So I'm Adrian Rušiec from the Maastricht University. I would like to show you this the presentation. So let's begin with the simple motivation. I have some 4 scenarios regarding that. So let's start with the first one. Imagine the situation that you are browsing the research software that is available, or any software actually that is available on the internet, and you want to try it. You want to install it and try what it does, what you can expect from the software if it's right match to your needs. So you are going to get the software, you are going to install the software. Probably you will be checking the dependencies, maybe fixing the dependencies, and if you are unlucky, you will definitely go through some problems installing the application because of maybe the version of the operating system or some missing dependencies or something like that. But you can fix that relatively okay, relatively seamlessly with the standard software, which is packaged by the within the package managers like apt or Conda or Python's pip package manager. Because it usually requires a lot of effort for the developers, which are investing the effort because they want to share the software, to prepare such a good package to be installed and used. So they usually test it on the various operating systems and versions and with various dependencies that the people can have on their local machine. But usually when you are starting or using the research software, or you are building the software yourself, you don't have that much time to actually document everything. So or document everything or test the software for it's called metrics testing, to test your software for the versions you have with various versions of the operating system and dependency and environment setting that could be out there. So this is the first thing that why we need or we want to manage the artifacts somehow in a managed way. The second one is that we need usually, if we are using such software, we need usually or we require some kind of a mobility of the compute, which means that if we are going to develop the software on our local computer with some kind of the dependencies, as I mentioned, so we will install some software that our software requires to be used. Then we want to make sure that on the desktop PC, so on my different computer or in the cloud environment, or even in some batch processing services like supercomputing facilities, the same software will work without this burden of debugging what will happen if the operating system will be on a different version or something like that. So you need we need the requirement to satisfy also this. So when I'm building the software on my laptop, it should also be run on the supercomputer without many changes to the software or to some installing process. Then you would probably like to have some kind of the basic security. This is very usually neglected by the users, by the academic users, also by me when I'm doing some software. But there are many cases of the dependency injection and using old dependencies in the software, which is not really what you would like to be run on the local machine, on your laptop. So this way you can somehow use also older dependencies and not expose all applications within your laptop or the cloud compute to these vulnerabilities. And the last thing is that we usually do is when we create some kind of a software, we have a publication, for example, here in academia for that kind of software, where we say what was our method, what the software is doing, and what's special about it. But then you have to again go and share it with the other colleagues, and you are doing it by either providing the whole code in services like the GitHub or some other version control systems, and with this, you would also like to tell them how they should install the application on their own machine, so it will work as you intended, basically. So the solution, I think you already know. The underlying solution is are the containers, basically, and so I will go shortly through some basics of the containers, and then we will show how we are supporting the containers in the EGI Artefact Registry. So so from the motivation, we can see that the containers or the software itself has quite the problems when we want to share it and probably also run it without any troubles, mainly when we are using not very standardized software which would be supported by the many developers out there. So that's why the containers come to the scene, and they are very popular nowadays to share and run the applications. They feature the minimal file system with only required application and the dependencies which are in the container package container image that your application requires to use. So it has a small footprint, and the benefits are that it is very easy to distribute the software. It is quite isolated from the underlying system. Only the kernel is shared. When, for example, with the virtual machines, you are also having its own kernel and the operating system. So the virtual machines are more heavy in terms of the performance overhead than the containers. So it is a beneficial, after all, in the academia for the computing and workflows. And as I mentioned, the users doesn't have to manage any missing dependencies because they will be installed for the application without interfering with what is already installed on the host operating system. So by this we mean the isolation of the data and the application from the operating system, from the host operating system, without having the virtual machines or some other features. In most operating systems, it is a native feature. In Linux computers, it uses the C groups and namespaces, and they are also available in the Windows. But I think that in these times, it is only it is also by having the containers API in the Windows kernel, so they can be native also for the Windows applications. But then you need to run it only in the Windows environment, which is not that common in the academia. So the most prevalent software for management of the containers, building containers, running containers, and maintaining its state on your computer is a Docker, and Docker container is some kind of a synonym of package software which is packaged into a container image, which could be run on local PC, VM, or somewhere else. So I have also a small showcase how you are building the Docker containers. On the right side, you can see how the file, the Docker file, looks like. It is very nicely, in a declarative way, describe what should the container image have inside it. So let's say we see the directives like the from, work dir, copy. These are the main directives used for the Docker, and it means, for example, if we will take the from, it will use the original image. So like the architecture of the Docker, you can layer image layers after each other. So you can basically reuse some kind of a software and only modify the layer you want. For example, I would say that I also add I would like to add some file into existing Docker container. For example, patch some kind of a file of a software, and then continue with the rest like the software has. So I can only patch one layer, for example. And we can build the container images this way. It uses the Docker build command, so it expects you to have this declaration of how the container image should look like in this format. The Docker itself has very nice documentation, and nowadays the AI also could help with creating such declaration. So it really isn't a problem. There are not that many combinations of directives, but of course there are some advanced concepts in the containers. For example, multi-stage build patterns and layer caching. So it is actually helping you if you are doing some really, I would say, nasty but really large software, and you need, for example, build it many times a day because you run some tests on each new version or feature you add to the software. And as I mentioned, you can run it automatically. So it is usually being run automatically within the CI, continuous integration services like GitHub Actions or GitLab pipelines. So the motivation is that you want to have the new container available with the new software after you push the code into the GitHub repository or the GitLab repository, or what kind of version control system do you have. So you want to use the pipeline mechanism for that and have the container image storage service that would store the images. So the pipeline is pushing to that container image store service, and it is then available to you. When one is building the containers, there are several considerations doing that. You have to prepare the software dependencies, basically to say what kind of dependencies will I have to use, because it depends from what kind of the base image you are starting from. But you can expect that in the image from this example that I show in the slides, that the Python 3.9 image would only have some basic or standard Python packages, and also only the version of Python in the version of 3.9. So you would have to consider what you are going to use, so you can add it into the resulting container image. For example, there will be no tools like curl or the web server or the Postgres database server. So yeah, you will have to think about what you are going to use in the resulting software. And in Python, you usually do that with the requirements file. So you can see that you just copy the requirements file to the container context, because in the process when the container is being built, it's called the context. And then in this process of building, you only run the pip install like you would do normally in a virtual environment of the Python or on your local machine. So it's pretty much very similar and intuitive to switch from how you are preparing your environment for your own software or for software to stepping into the container images. So I have also a few tips. The container itself, as I mentioned, you want to think also about some kind of a security inside the running containers. For example, you don't want to install additional software in the runtime of the container. It is really meant to be pretty much self-sustained. And if you would go through the software installation because you are debugging or doing something, you can install, for example, things to the home if you are not running the container as a root, and then you also have to have all the libraries and software dependencies in that case. So it is not meant to have it like a real virtual machine. So so yeah, you have to build it for the each iteration you want to add maybe tool or some kind of modification to the software. Writing in the software is in the container image is also possible in the temporary or home dirs if you are not specified otherwise with the home or chmod directives or the commands. But this applies also when you are running non-root. If you are root, then you can basically write everywhere. But these modifications to the container images aren't persistent, so they are not going to persist. If you are going to kill the container, the process within the container, you are not going to get the changes when you will start the container again. For that, you need to attach the external volume, the storage, so you have the persistence in the container image, and by this way, you can configure the or you can prepare also your application that it should only write to some temp files or the temp folder or the home folder or where it actually resides the application, and you will also have to prepare the application that the external storage might not be there, but it depends how you are going to, if you are going to need that to be as external storage for the persistence, of course. Okay, so now let's move to the storing containers, because I touched the topic with because when you are going to build the container, you want to store it and share it with the other colleagues and also with the infrastructure, so the infrastructure knows where the image can be found, so it is executed properly. So container images are stored in the software or services called container registries, and we recognize the several types of the container registries. We know the local one. It comes pre-built. If you are using Docker, it comes pre-built within the Docker software, because you are going to primarily you are building the images on the local computer when you are going to try it or demo it or download existing container image, and that's for the local container registry is there, and you can see by yourself if you have container images by checking the Docker images command. Then we have the remote service. This could be provided by the private company, and they are mostly, but also by the infrastructures, and they can be public, and they can be private. The public container registries are, for example, the Docker Hub, or the GitHub has its own container registry service, which is bundled by the repository itself or the project itself. You can use the quay.io, and there are many container registries out there. But the thing is that when they started to operate, they were mostly free to use. But nowadays we can see that some companies are starting to restrict the usage of those platforms and those services. For example, they require you to only have the artifacts stored as a public projects, so anybody can read it, which is very usually okay. But there are some cases when you don't want to share the container image to the public. Like you don't want to share some kind or pieces of the software. And some companies or some registry services are starting to rate limit the usage of the container. So they are going to tell you that okay, for your IP address you can download 100 containers in a week or day or month or something like that. And you can imagine if you are going to if you are going for some scientific workflows, when you are going to use the workflow manager, which will be running the Docker container on many nodes of the computing platform, then you would be easily basically hitting the limit of too much of the downloads of your image, or the downloads within some IP address if the cluster is inside one IP pool, for example, the university pool. This actually happens for the Docker very strictly. I mean, each year it's I would say it's the limits are stricter. So there comes the freedom of having our own container registry, which is thankfully provided by the eScience Center, such as the EGI, and that's the registry.egi.eu service. So what it really is, it is a way how to store the OCI compatible. It is the acronym for the Open Container Initiative standard. It is some kind of a community standard, but very well adopted for the container images. They follow that. Like many orchestrating platforms or the building platforms like Docker, Podman, Kubernetes, OpenShift, and many more. It only says that the container should be in some kind of a package, and it should be somehow be run, and it should somehow be stored in the layers that supports cache and etc. So and you can have the registry service for the container images which supports that, and we have that. It's called EGI Artefact Registry. You can see yourself the domain I mentioned, and the access is basically granted by the project. It will come also with the project within the container platform, which is also provided by the EGI. But if you are interested to have a project where you can store the artifacts for your own project or your own group, then you can easily ask and contact the EGI support with the name of the project or VO, as it's usually done with the EGI, and get a quota where you can store the images. So then, for example, the image URL looks like this registry.eu. Then there is the project name, which in this case is the vo.demo.egi.eu. And then you have, as the last part, you have the name of the image itself with the tag. In terms of the containers, we usually talk about the tags. So this whole basically thing is a container tag, which is the name of the container, some kind of an identifier. So the container orchestrator knows what kind of image are you using. And you can interact with the service with the native tools like the Docker. You can log in to the Docker registry. You will only need the command line token to have generated from the registry.egi.eu, but we have it in the documentation. I'm having the link here in the slides. And then if you have some local container, for example, I have the Gromax Adrian page, then you can retag the image with the prefix of the URL with your project you obtained, and then you can push this image into the artifact registry. Some features which Artifact Registry has is that it supports storing the OCI artifacts, but the OCI standard is starting to be, or it supports not only the container images, but you are able to store also the Helm charts, which are the recipes for deploying or templates for deploying the software or the infrastructure to the Kubernetes. And it also supports storing the virtual machine images. So if you recognize those .qcow or .raw files with the whole virtual machine, then the EGI Artefact Registry can support that and store that as well within the project. It has very nice access control settings, so the project could be public or private. So when you are going to do the software and you want to publish it to anyone in form of the container image, then you can select that you want your project to be public, and then it is like any other public container registry, except that we don't have rate limits and we don't have these restrictions, other restrictions on the service. If you want a private project, then you have ability to have granular permissions for the project. For example, for the administrator of the project, he or she can then manage the some policies of the project. Then you can have the maintainer, which is able to push or pull the images as he wants, and then you can have the guest who only can look at the metadata of the project, for example. And the very nice thing is, and I would say it is pretty expected from platform as such, that we have the robot accounts for use in these automatic pipelines for building the container images. So you can generate the container, you can generate a robot account, you can give it permissions only you need, basically. So for example, I would say I am using the container, or I'm using the robot account from the GitHub pipeline, or the GitHub action, as it's called in the GitHub terms. And I will give the robot account permissions only to push to the container registry, to the EGI Artefact Registry. So it doesn't do anything other than writing a new built image into the registry service. You actually want to use also the read permissions, because that's how the build process is going to fetch for the caching, for the layer cache. So we want also read, so the robot can actually check if some layers of the container image are not the duplicates, so it can skip building them and only reuse. So yeah, but it's just nice. It is a nice feature, and you can also use the robot account to manage the whole project, for example. So manage the users if you have some automatizations and you want that. You can manage, you can talk to the API of the service with these robot accounts for any other things, which is, for example, one thing. If you rely on some security, you can have the security scanning, vulnerability scanning within the artifact registry. So it is going through the known software libraries, or for example in Python the pip packages, and known CVS, and it will tell you that it will tell you that after the scan you will get the report that your image has high severity, uh, uh, some high severity, not errors but vulnerabilities in the image you published, and you can then do some update of the images or something like that. And I'm saying about it in context of the robot accounts, because that could be a step of the pipeline, that if the Docker if the build was successful, then publish or push to the artifact registry, run the vulnerability scanner, and then report back if with the state of the pipeline, if it was failed, if the vulnerability scan failed, then fail the pipeline, or something like that. That's not, I think it's not very usual that somebody would do that, but you could. Then you can sign the image. It is something like the code signing from what we know in Windows or Mac OS. So you can really add a layer of the signature of the software for your certificate. So it could be then trusted that you are the really one who built the container. This could be interesting, for example, for the trusted research services. And then you can specify in the artifact registry that you only want to push the images which are signed by some trusted certificate authority. Then you can use the lifecycle management, for example, have the retention policies for the images, to say, for example, that to say that, for example, I want 10 last versions of the container image, and it will automatically, if you push another one, it will automatically deletes the last one, so you don't use that much of the space, and you don't have to manage it by yourself, because there is the automatization. And you can also say that if the image is tagged like the production, or you really rely on that, then it will skip that. It can do also some replications between the registries, so you can set up it like the mirror of your another registry, for example, some internal ones that you have in your organizations, because many of the universities have its own kid lab with the container registry service, but it's not meant to be so the software within this within those within those GitLab instances are shared with the international communities, for example. So you can then mirror the images to the EGI service and then use that as a point to share. And then it can do the proxy for the upstream registries, for example, for overcoming the Docker Hub rate limits. So the EGI Artefact Registry can serve as a cache between the Docker Hub and its own infrastructure. So, for example, if you will be using some computing service from the EGI, we can set up that you will be downloading or the it will be if it will be Kubernetes service, then we can set up so the Kubernetes will ask the EGI Artefact Registry to use the known image, for example, from the Docker Hub. So it is downloaded only once, and so then the Kubernetes are only talking to the EGI Artefact Registry. So these are the niche or nice features that that could be used in the projects or when you are some kind of a research group. I have the images now in the slides, so we can see that we have the EGI check-in login to the service, so you can use your existing EGI check-in account. And after login, you will see the list of the projects. Some of them are in the public setting, as I mentioned, that they are like that they are there to be shared with the other colleagues, for example. But you will see yours if you will have one as well in this table as your own project. And this I only wanted to show that you can create a robot account in the project. I wanted also the project. Oh, okay, never mind. We can go through the website in following minutes. And I also wanted to only have a very simple slide about using the containers. So then if you are going to use the container or share with the colleague, he or she can use the common ways to run it on a local computer with the Docker, or with the Docker on the remote PC, for example, in the EGI Fed Cloud services, or it could be used as a source image in the Kubernetes platforms, like the containers.egi.eu, or this can be also used. Sorry about that. This could be also used in the batch processing when you are using, for example, the workflow managers like the Nextflow or the Galaxy, where you again specify where the image is stored and it is there. Usually, you need the authentication to the project or to access the container image if your project, as I mentioned, is set as a private. So you will have to log in first with your credentials you have set with your account. You can then see in the documentation how you are going to obtain the secret for that, because we are using the EGI check-in. So you don't log in with some username and password. And yeah, you will need that probably if you're using the private account, also a private project, also in some workflow managers like Nextflow or Galaxy, and Kubernetes as well. And that's why we have that's why there are the robot accounts, so you can set them to read the container registry and your project to download the images. Okay, and this is only really one of the last slides regarding the cloud container platform, where you can actually execute and reuse the containers. It is very close to the artifact registry. So even if you will be using some 40 gigabytes of the image size, which is very common nowadays with the AI models or with the AI training software, for example, then you can use the power of basically this interconnection of the to the container platform. And we have very nice documentation how you are going to use that. So this is the benefit basically that you have. And the EGI Cloud Container Platform is built on the Kubernetes. Users will be provided by the project and the quota, which is defined as a CPU and the operating memory on request. Again to the EGI support, and the users then can create their own namespaces and organize the things within the Kubernetes project as they wish. And you can also bring your own Kubernetes cluster, because the cloud container platform is the management for the Kubernetes with some additional perks. So it is then integrated with the EGI check-in for the login and the authorization, where you can also set up some level of the granularity, of course, and it can be actually shared with the access to the compute and access to the artifact registry. So it creates this nice seamless connection between those services. You can request, as I mentioned, you can request the computing resources with the EGI support through the free tier. So you get some small amount of the CPU limited only to the short time, but you can also get the guaranteed resources, or if you have the your own cluster, then you can use that and enjoy having the managed administration portal for your Kubernetes platform. So this is only the overview what it really is and where you can find it. So it's on the containers.egi.eu, and you can actually try running, for example, well, if yeah, okay, I forgot that you might not have the access. You have to request for that, but sorry. But otherwise, you could try running some Docker container in the Kubernetes if you haven't done it yet. Okay, and I have here a time for a demo, but I think we have six more minutes. So maybe let's just quickly show my terminal. And if you already have some questions, then please don't hesitate to ask. We can discuss if it's useful for your project and what are some, I don't know, consequences, or what you are afraid of using using the artifact registry. So I have prepared the small container image. It is for some very demo application, which is exposing some API endpoint to the internet. And you can see that it does what I said, and it uses the advanced multi-stage build, where in the first from directive is the builder, where I'm going to update the packages, install the Python requirements, and then in the base image, which is the image where the application will be run. I'm going to copy the requirements which were installed, and I'm going to copy the application itself and set, for example, the user to be user 1000 and not root one. And then I can set up also some environmental variables if I want to show that in or if I want to use that uh, in the application. And then what is going to be command which will be run if I'm going to run the Docker container. Okay, so but that's maybe a bit a different topic. So let's see that I am going to build this image. I will use the Docker build command, and I'm going to write the tag for it as we showed in the slides. So let's say I have the demo.egi.eu project within the Artefact Registry, which is my project, and I'm going to name this application like I would like like we do. So I will name it as the app, and I will give it a version number, so I know that it's the application of the version 1.0. For example, you can use the commit hashes from the GitLab or GitHub, so you really can pin to the very correct, very specific version when you are deploying the infrastructure, so you always know what kind of version of the software you are actually using, because that could be also a pain when you will be using something like this, which is the default. And if you are going to do the latest tag, you will be rewriting the latest tag with always some new version, and it will be not very uh, it will be not very you couldn't be sure what kind of version you would then have installed on the first site. So by this I can pin that in this container image I'm having the version of the 1.1.0, so I will know that what's in there. So I can hit the enter. Yeah, and I the last dot says that the context of the build context is within the current folder, basically. And this means that in that current folder there should be a Docker file, really the file called Docker file, and the files of the application we are using then in the Docker file. So for example, when I use the directive copy from local folder for the init file, I really mean that it is from the local folder, because I put the context of the doc. Okay, but this was again a bit of diversion from the original course. So we can see that that we have the image tagged and ready as this, and I can actually run it locally, as I mentioned, with some with some yeah, with these parameters. I don't want it to be interactive. I don't mind, but I want to have the ports exposed. And I'm not sure which ports I do have in this application, but that's don't mind that. Yeah, I already running the application with the with the another port. Okay, but let's say the application would run just fine, but it's not very important for the case now. So I'm going back to my projects. Yeah, I will have to log in because the session expired, obviously. Sorry about that. So you can actually see the whole process of so how it's done. Yeah, registry service. No, 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 no. I want it the SSO. Yeah, it's this one. Okay, so I will log in now to the service, and I can see that that I have the private project called the demo.egi.eu, which is empty, and you can have the help here that will tell you or instruct you how you should push or the tag the image so it's prepared for the registry.egi.eu and how to push, how to pull, and also how to do that for example, for the Helm packages, but also for the any other OCI compatible packages. So let's say I'm going to do that. I'm going to push to the registry, but I will have to use the Docker login. So I will say that I want to log into the Docker to the registry.eu the registry.egi.eu, and I will use the username which I see here in the menu in my user profile, which is my EGI username from the check-in. So it will need the password from me, so I can use this CLI secret. I can copy it without you seeing it, so it's pretty smart. And I can paste it into the console, and I see that I am already logged in. Now I noticed that I uh, used the wrong name for the repository, which would not allow me to push there because in the web on the website we can see that I have the name for the project called demo.egi.eu, but in the tag I used the vo.demo. So we can fix that actually because we can add another tag by using this command, and we will do just that, and we will edit the repository, the project, and we will keep the rest. So it was successful, and now I can say that I am going to Docker push to push the container to the remote container service registry. And we can see I just did that. Then if we refresh the site of the artifact repository registry service, we can see that we have the container image. And here, for example, we can see that I can run the vulnerability scan or do some other actions with the container image. And for example, and this is one thing that could be automatized within some GitHub actions and the robot accounts, that for example you would also like to add some other tag to the image. So not only when you are building it and pushing it, but also from the web UI. And now the image will be recognized and could be run with the tag that I used here. So let's just try that. I'm going to pull that image, demo.egi.eu up, and I didn't want that. I wanted to only use this one, but it's good to see that if you are going to use the button for the copy, it will copy the whole Docker pull command, so it's easier to use. So when I'm going to so I pulled the uh, the container image, and with the different tag on it, and you can see that it was found and downloaded. So pretty much this was the demo and the presentation, and I hope you enjoyed it and it will be useful for your projects.
Thank you very much. Thank you. We have a already question in the Q&A box, and Yuri, I can enable you to talk actually, and well, Andrea can look at the Federico, can you enable Yuri to? Yes, thank you very much. And he asked how much you connect your proposed solution to the research reproducibility. Yuri, do you want to clarify your question?
Yes, actually, I can just confirm. Artifact is clear, it's everywhere, it's available. But for research reproducibility, do you hear me? Because something on my computer. Research reproducibility actually means that you need to fully document your artifact and also provide a set of metadata well defined. Do you have this already in your?
You can the OCI standard actually supports the specifying the metadata, and for the Docker containers, it is very common to specify the custom metadata, specifying, for example, maintainers, authors, description, name of the software, version, and this kind of information. So it is really nicely traceable who made the software, who published the actual software. So yeah, you can use that, but it's a native feature of this containers itself. In the registry service, in the artifact service, again, this is more for the or used from the infrastructure point. So I'm going to do some computational workflow, or I'm going to share it with my colleagues so they have the same environment. And you can use this as a storage for your container. But if you are going to publish the software to some kind of a software catalog, for example, the Bioconda or some other software catalogs which support also the containers, then you can use the link from the EGI Artefact Registry, or upload that artifact for the publishing the software to the Bioconda, for example. Yeah. So this is not completely service for like making a catalogs of the software. This is for more like in this infrastructural way. When you are going to develop something, you are going to operate some kind of application, and you want it to be always available. I mean the source code, the container image, and you want, for example, to share it with your team.
Okay, I would I'm happy that I didn't know about the artifact service. But still, for us, it's important that if we talk about reproducibility, we need to have well-defined and a separate document what kind of metadata, what kind of information can be recorded, or it should be separate registry for metadata. I know about OCI, I know about Kubernetes, but this is something internally
Yeah,
known.
okay. Yeah, okay. I'm trying to understand if it's like in this generic academia way that we want to publish reproducible software in some way, or if it's the use case for the internal documentation for this software.
Because also continue this discussion because no questions, other questions. If we talk about reproducibility, we can document what you have now. But
Yeah.
what to do this, all images, artifact that is done next previous 50 years. So we need to also have well-defined metadata structure to do the extraction from the, say,
Yeah.
old artifacts. So documenting this would be beneficial. I would happy to know if you will continue, will do this.
Yeah, okay, I see. Yeah, and actually the Artifact Registry service supports you to have this this markdown description of the repository for the software and also the metadata. So of course you can do it for the new images. But yeah, it's interesting thing that we would like as well to describe the older software, because as I'm I'm the member of the tools platform in the Elixir, we are having this kind of a discussion there, what to do with the already published software, which is in term of the GitLab or the GitHub repository link, and it was some output or result of some PhD work, but the method, for example, is kind of good if you found it and you would like to use it. But you are not going to, because it was coded in Python 3.7 or something. Nobody did the container for the software. So is it actually a valid like thing to have in these catalogs, or it is something that should be forgotten, for example? But it is interesting aspect that you can even get some information also from not working code and not reproducible software. So yeah, also for the containers as well. Yeah.
Okay, for the time's sake, and it's very good for this point for future probably discussion. And Yuli, I hope you are happy with the answer at the moment. We can continue this discussion offline. And we have a final question from Andrea Shivi and Federico. Can you please enable? Andrea, can you talk? You are muted. And anyway, the question is in the Q&A box. What's in the Q&A box? And is thank you for your brilliant presentation. It would be possible to push several apps, Docker images, and it would like app 1, app 2 into same repository. And
I can answer that. Into same project, yes, but then it will create or you can you can create the basically hierarchy there. So you will have the up 1, up 2, up 3, or yeah. So I'm not sure if
Does it answer your question, Andrea? Okay. Okay, we are running out of the time, and then I'm sorry I rushed to wrap up, but I give a great thanks to Andrea for your excellent work. It's from the research to final production level and deployment is excellent work. And thanks to our audience, thanks to your question, Yuli, and also Andrea, you raised a very important aspect to future improve this research. Probably we can offline continue the discussion. Thanks to Federico who worked behind the scene, ensure everything work well. And thanks for everyone. I want to invite you back and to the next webinar. Also, looking forward to see you in our EGI conference. Thank you and enjoy the rest of the day.
Thank you for having me. Bye bye.
Thank you, Carl Frederick. Thank you. Bye bye.